വേറെ സ്പീക്കറുണ്ടോ? ഇവിടുന്ന് കേൾക്കണേ.
അതൊന്നും ഇതിനകത്തേക്ക് വരേണ്ട ആവശ്യമില്ലല്ലോ.
വേണമെങ്കിൽ ഈ സാധനം വേറെ ഉണ്ട്.
നോർമലി പറഞ്ഞാൽ പോരെ, മൈക്ക് വേണം. കുഴപ്പമില്ലല്ലോ, ഇതിനകത്തേക്ക് അങ്ങനെ സൗണ്ടിന്റെ ആവശ്യമൊന്നുമില്ല. എങ്ങനെയാ ചെയ്യാം? അതെ, ആരംഭമാണെങ്കിൽ ആരംഭ. തുടങ്ങാനൊക്കെ എന്താ ചെയ്യേണ്ടത്? തുടങ്ങായിരുന്നു മനസ്സിലാവണല്ലേ അല്ലേ?
ഹലോ. ഓണം. ഹലോ.
ഹലോ. ഹലോ മാമ നോക്കുന്നുണ്ട്, പറഞ്ഞുതരാം. ഇവിടെ ഉറക്കെ ഇവിടെ കേൾക്കില്ല അല്ലേ? സാർ ഇതെങ്ങനെ വെക്കുന്നത്? ഓക്കെ, ഇവിടെ ഇരുന്നാൽ മതി. ഓക്കെ, അല്ല എനിക്ക് എന്തെങ്കിലും അല്ലാതെ പറയണം എന്നുണ്ടെങ്കിൽ അല്ലെങ്കിൽ ഈ മൈക്ക് യൂസ് ചെയ്താൽ കേട്ടില്ല. നമുക്ക് വേറെ എന്തെങ്കിലും പറയേണ്ടപ്പോഴേ ഇത് മാറ്റിയാൽ മതിയല്ലോ. ശരി ശരി. Elizabeth Miss. Elizabeth Miss. So warm good morning to all. So almost all are familiar. A hearty welcome to all of you to the third day of our FDP, Machine Learning from Fundamentals to Deployment. And this is the first offline session, and we are so happy that we could meet you all at our institution. So on behalf of our Computer Science and Engineering Department, on behalf of Vishijyoti College of Engineering and Technology, we welcome you all. So as we know, our resource person, Dr. Jisha Mariam John, ma'am, she has already handled the session on our first day, and she had already covered the concepts, introduction to ML. The schedule is already shared in our group. You can have a look at. Then classification of ML, supervised learning core concept, parameter estimation, supervised learning technique, then regression algorithms, then classification algorithm, till KNN, ma'am had handled on the very first day. So we'll be having the lab session also based on those topics. And once again, let me introduce Dr. Jisha Mariam John to all of you. Dr. Jisha Mariam John is an assistant professor at the Indian Institute of Information Technology, Kottayam. She holds a PhD in computer science and engineering and specializes in complex networks, graph-based machine learning, climate dynamics, and epidemic spreading models. She has published several research papers in reputed international journals and conferences, and has received prestigious awards, including the doctoral fellowship from IIT Palakkad Technology iHub Foundation, and also received Anusandhan National Research Foundation International Travel Support for participating in the 6th edition of Complexity 72 Hours, an international workshop held from 23rd to 27th June 2025 in Madrid, Spain. She is an active reviewer of leading journals and a professional member of ACM, ISTE, the Network Science Society, and the Complex System Society. So such a rich profile. We are blessed to have Dr. Jisha Mariam ma'am here to handle the session today. So with utmost honor, on behalf of all the participants who have gathered here, I welcome Jisha ma'am to today's session. We need to have a self-introduction session, so probably we'll keep that in the afternoon session because all are busy with the settings and introduction part and all. So we'll do that in the afternoon session. So right now, let's begin. Over to you, ma'am. Thank you. Thank you all. Have a great day. അല്ല ജസ്റ്റ് പേരും കോളേജും പറയാം നമുക്ക് എവിടെ നിന്നൊക്കെയാ വന്നേന്നൊക്കെ അങ്ങോട്ടും ഇങ്ങോട്ടും ഒക്കെ ഒന്ന് അറിയാൻ. ആര്യാമസൊക്കെ പറഞ്ഞേ അവര് വേറെ കോളേജിൽ മുപ്പത്തില്ല എവിടെയോ പോയി കഴിഞ്ഞപ്പം FDP കഴിഞ്ഞിട്ട് വന്നത് ആരൊക്കെയാന്ന് അറിയത്തില്ല. അപ്പം ജസ്റ്റ് ഒന്ന് പേരും കോളേജും മാത്രം ഒക്കെ ഒന്ന് പറഞ്ഞാൽ മതി. അതിനിപ്പോൾ ഇവിടെ അടൂരിൽ നിന്ന് വന്നിരിക്കുന്ന 4 പേരൊക്കെ ഉണ്ട്. അടൂർ കോളേജ് ഇവിടുത്തെ അറിയാൻ ഏത് കോളേജിൽ നിന്ന് ആര് വന്നു അത്രയും പറഞ്ഞാൽ മതി സാറേ. നെയിമും കോളേജും മാത്രം. അതും ബസ് ചെയ്യുമായിരിക്കും. അതെ അതും പറയും. അത് മറ്റേ ഡോക്യുമെന്റേഷനും അതെ എടുക്കാം. ആര്യാമസെ അറ്റൻഡൻസ് ഇതിൽ കൂടെ നടക്കും. അല്ല അപ്പൊ ഞാൻ സെൻഡ് ചെയ്താലോ ഇതിനകത്ത്.
Okay, very good morning to all. In the last section, that means in the first session, we already discussed what is machine learning, and then the different paradigms in machine learning, like supervised, unsupervised, and reinforcement. Then in the first day, we discussed different supervised algorithm. Yesterday, I thought ma'am covered the unsupervised algorithm, right? Then the first one we discussed is regression, right? So what is regression? കേൾക്കുന്നില്ല. മനസ്സിലായി മനസ്സിലായി.
എക്സാം ഇപ്പം എടുക്കാൻ നോക്കാം. അത് കൗണ്ട് ചെയ്യുമോ എന്നുള്ളൊരു സംശയം ഉള്ളതുകൊണ്ടാണ് അതിലേക്ക് വെച്ചു.
Audible? Okay. Then, yeah, coming to regression. What is the meaning of regression? It is a supervised learning technique. Why it is not a supervised learning? Yeah, for the data, we will have the labels. For each data, we will have the target variable, and that means label. We already know what is the output, right? For the data, for the given data. Then regression is one of the technique. It is mainly used to predict some values like price of house, salary of a person, and then whether the mail is a spam or not. Such kind of thing we can predict. That means some continuous values we are predicting, okay, in regression. And the first one is, first regression we discussed linear regression. In linear regression, there are several types. The first one is simple linear regression. In simple linear regression, what happened? Only one feature we are considering. That means in order to find out the house price, we will consider only one variable, maybe the square feet of the house or number of rooms available in the house, right? So in simple linear regression, we are considering only one variable. Then coming to multiple linear regression. In multiple linear regression, what is the case? We will consider multiple features. That means in order to predict price of a house, we will consider number of rooms, then square feet of the house, then location of the house. Multiple features we will consider, right? Then coming to another regression, polynomial regression. In that case, what happened? In linear regression, we assume that there should be some linear relationship between the variable we consider and the target output, right? There should be some linear relationship. That is the one assumption. But in some cases, it is not true. It may not be true. That time, we will go to polynomial regression. That means our data will be represented as a curve. In linear regression, in simple linear regression or multiple linear regression, we will represent the data, or we will try to model the data using a straight line. We are trying to fit a straight line into the data. But sometimes in real data, there may not be a linear relationship. So in order to capture such kind of non-linear relationship, we can use polynomial regression. Then in all these cases, what is the main aim? What is the objective, or what is the goal? Yeah, predict the output, but yeah, predicting some numeric quantity. Then yeah, we want to minimize the difference between predicted value and the actual value. That means we want to reduce the difference between that two value. That is known as the difference between the actual value and predicted value is known as error, right? Some of these errors, we will calculate the difference between predicted value and actual value for each data point. Then we will take the sum, right? Then that sum, that error, that total error should be minimum, right? That is our main goal. So we want to find out the best line that fits to this data such that our error should be minimum. Okay. Then the data we can represent using the equation, linear equation y is equal to bx plus c or a mx, like that way. Then what is b indicate? Y is equal to bx plus a. In that case, what is b? It is slope. What is the meaning of that slope? What that term indicate? If we change the feature, for example, if we change the square feet by 1 unit, then how much our house price will increase. Okay, if we change the x-axis by 1 unit, then how it will reflect on our target variable. Okay, that is the meaning of slope. Then what is the meaning of intercept? Y is equal to mx plus a. Then that a indicate intercept, right? So what is the meaning of a? A is the intercept on y-axis. That means when x becomes 0, when our feature becomes 0, what will be the value of y, target variable? In real scenario, that means there is no meaning for a house with a size 0, right? But actually, we use the mathematical models to represent the real world data. Okay, so here we have the data and we have the features, and for each data we will have the target variable. Then we want to find out the best line that fits these data. That is a simple linear regression, right? Then our first lab I want to show is all of you please log in into the Colab. Just Google Colab. You can sign in into the Colab using mail ID. ഷെയ്ഡ് ആണല്ലോ. അല്ല നേരത്തെ ഷെയ്ഡാണ്. എൻ്റെ സ്ക്രീൻ ഞാൻ ഷെയർ ചെയ്തേക്കണം, ഒന്നുകൂടെ വേണമെങ്കിൽ ചെയ്യാം. I hope all of you signed into the Colab, right? Then you can take file, click on file, okay? Then new notebook in Drive. If you already have some notebook, then you can use open notebook, okay? Yeah, I already created the notebook one called a linear regression. ആദ്യം ഷെയർ ചെയ്തായിരുന്നു, ഇപ്പൊ സ്റ്റോപ്പ് ചെയ്തായിരുന്നു. Okay. Then you can save the file by renaming here. You can give any name. Okay. Then if you move here for these rectangle is known as cell. Okay. If you move here, you can see two things. One is code and one is text. Okay. Then if you click on this code, you will get another cell for writing the code. Okay. If you click on text, then you will get a text box. In that you can type the different notes. As if you give it to the students, you can give the notes. Okay. So for every cell in top and bottom, you can add code and text. Okay. Clear? Then for running each code, each cell, here we will run the each cell by cell. Okay. For running the cell, here you can see a play button. You can click on that. Okay. Then we can move to the I have uploaded the first file linear regression 1 in the drive. You can take that. Then our first experiment is to implement the linear regression with one variable on the California housing data set to predict housing prices based on a single feature. Here we are considering only the single feature, and that feature is average number of rooms per dwelling. And the task is to load and pre-process the data, implement linear regression using both gradient descendant and normal equation, evaluate the model performance using metrics such as mean square error and R square, then visualize the fitted line along with the data point. Okay. Here I am just trying to give the basic. You can experiment the same code with the different parameters. You can change. Okay. Here just I want to give the basic thing, basic code structure. Okay. Then so firstly the first thing we want the data, right? So our data set is California housing data set. Okay. All these data sets are available in the Kaggle. You can just search this housing, California housing data set. See, just California housing data set. Okay, just search. Then you can see the Kaggle website. You can go to that. Then here you can see all the details of this data set. Okay, that means here if you click on data card, you can see the details like what are the features included in this data set, like longitude, latitude. It represents how far the house in west from the west and north, and housing median age, and total rooms, total bedrooms, population, households, median income, median house value, ocean proximity, like that. Okay, then by clicking on combine you can see the values. Okay, then column, by clicking on column you can see the different statistics of this data set. Then if you want to explore more about this data set, you can see the here code. You can click on code. Here you can see there are 1452 different experiments are already done on this data set. You can click on that. See, different like California housing prediction using ANN, and different random forest versus cat boost. Different algorithms are already implemented. See, here also you can see linear regression using California housing. Actually, already it is implemented in this Kaggle. You can explore. Different algorithms are already implemented on this data set. Okay. Then discussions are there, some suggestions are there. Then if you want to download this data, if you want to download this code, a particular code, select that code and you can download here. Then you will get that particular Python file. Okay. Then if you want to download the data set, you can see here Data Explorer version 1 housing.csv. You can download that data set. Okay. If you are using the Jupyter notebook, you can download this data set and upload. You can upload to the Jupyter notebook. I hope you got the idea how to get the data set. Yeah. Then here I am in the drive. In the drive, I will upload the data set housing.csv. This is the data set we have. I have uploaded the data set. You can download that one. In the drive, uploaded housing.csv. Or otherwise, you can directly download from the Kaggle. Okay. Then, actually, this data set here in this task, we want to predict the median house price using California housing data set from StatLib repository. It is already a built-in data set in the Python libraries. Okay, you can directly download that. I will tell that one. And the data set is based on 1990 California census and has metrics. It is a supervised learning technique. Here we are trying to perform the supervised learning technique because it is a labeled training, right? Here we are using the labels. And the output is median house price, which represents median house price for a district. Okay. Then the first step is to import all the libraries we require. So import numpy as NP. What is numpy? Numerical Python. We are importing numerical Python as NP. Why? What is the meaning of that sentence? Import numpy as NP. We are now onwards. We are calling the numpy as NP. That means NP is an alias name for the package or library numpy. Okay. Then import pandas as PD. Numpy is mainly used for the mathematical operations and calculations. Okay. And pandas for handling the data frames. We are handling the data as in the form of rows and columns. Then import matplotlib.pyplot as PLT. For plotting purpose, we are plotting the matplotlib. Then from sklearn.model selection, importing train test split. That thing I will tell why we are importing that things. Okay. Then in order to directly downloading the California dataset, you can use from sklearn.dataset import fetch California housing. That line I was commenting. Okay, then use data equal to fetch California housing. Then read that data as data frame. Okay, that cell is actually for directly importing the data set. Rather than downloading from the Kaggle, you can use this one. Actually, because this data set is already defined in the sklearn. So you can directly download. Then, if the another way is we already downloaded, right? So from the column, you can read that file. That I will show. Here you can see the table of contents, right? Click on that. Not table of here the files, right? The folder symbol. Click on that. Yeah, here you can see the sample data. Then click on content. Anywhere you can upload the data. Here I am uploading. The path is content, then hands-on, then housing.csv. So I go to the content, then click on these three icon, then create a folder, new folder. Then give the folder name as hands-on. Yeah. Then open the hands-on. Then click on these three dots. Then you can upload the data housing.csv. See, inside the hands-on housing.csv is uploaded. This is the one way to read the file. Clear? And then you can give the path as housing equal to pd dot. That means we are reading this CSV file as data frame pd dot read underscore CSV. Then give the path name. You can give any path. Wherever your data, you can copy that path and give that path here. This is one way. Otherwise, you can directly download or import this data set. You can directly import this data set from SQL.
ഡൗൺലോഡ്സിലുണ്ട് പക്ഷേ ഈ ഹാൻഡ്സ് ഓൺ ഫോൾഡർ ക്രിയേറ്റ് ചെയ്ത് പക്ഷെ അപ്ലോഡ് ഓപ്ഷൻ
അത് സിപ്പ് ഫയൽ ആയിട്ടാണ് അത് ഡൗൺലോഡ് ആയി എവിടെ അതെടുത്ത് ഓപ്പൺ ചെയ്ത് അത് ഓപ്പൺ ചെയ്ത് ഇതാണ് ആക്ച്വൽ ഫയൽ. അത് സിപ്പ് ഫയലാണ്. അതിനപ്പം എക്സ്ട്രാക്ട് ചെയ്ത് എടുക്കണം. അപ്പം ഞാൻ ഡയറക്റ്റ് ആയിട്ട് ഡ്രൈവിൽ ഇട്ടിട്ടുണ്ട്. നിങ്ങൾക്ക് അത് ഡൗൺലോഡ് ചെയ്തിട്ട് ചെയ്താലും മതി, അല്ലെങ്കിൽ അതിന് സിപ്പ് ഫയലിൽ മാറ്റിയാലും മതി. ഡ്രൈവ് എടുത്ത് ഒന്ന് റിഫ്രഷ് ചെയ്യാവോ? ഇത് ഡൗൺലോഡ് ചെയ്തിട്ട് ചെയ്താലും ഞാൻ രണ്ട് രീതിയിൽ കാണിച്ചേ ഉള്ളൂ. നിങ്ങൾക്ക് ഏത് വേണമെങ്കിലും യൂസ് ചെയ്യാം. ഇങ്ങനെ ഇമ്പോർട്ട് ചെയ്യുമ്പോൾ ഉള്ള പ്രശ്നം എന്താന്ന് വെച്ച് കഴിഞ്ഞാൽ ഓരോ പ്രാവശ്യവും കണക്ഷൻ ഡിസ്കണക്ട് ആയി പോകുമ്പോൾ എന്ത് പറ്റും? നമ്മൾ ഓരോ പ്രാവശ്യം ഈ ഫയൽ അപ്ലോഡ് ചെയ്തുകൊണ്ടിരിക്കണം. മെയിൻ പ്രോബ്ലം. സോ ബെറ്റർ വേ ഈസ് ടു ഡയറക്ട്ലി ഇമ്പോർട്ട്. For copying the path, you can click on these three dots. Here there is an option for copy path. You can just copy and paste. Okay, there is an option for copy path. You can click on that and just paste. Then first I want to know some information. Information method helps to get a quick description of the data, such as what are the columns in that, what are the number of non-null counts, and data type of each column. For that, you can use housing.info. Then here we have 10 features, and the name of the features are longitude, latitude, housing median age, total rooms, bedrooms, population, household, median income, median house value, ocean proximity. And the number of non-null count are also already given. And the data type, you can see from the features 0 to 8, all are floating values, right? And the last one, ocean proximity, it is an object file. It is not a numerical value. You can check in that data file. You can see that ocean. See, the column ocean, it is not a numerical value. Ocean proximity. Clear? അത് റൺ ചെയ്യണ്ട, ബിക്കോസ് നമ്മൾ കമന്റ് ഇട്ടേക്കോ. ഇഫ് യു ആർ ഗെറ്റിംഗ് എറർ യു ക്യാൻ ഗോ. അവിടെ കണ്ടോ എക്സ്പ്ലെയിൻ എറർ എന്ന് പറഞ്ഞ് കിടക്കുന്നുണ്ടോ? അത് ക്ലിക്ക് ചെയ്തേ. ഒരു 1 സെക്കൻഡ്. എക്സ്പ്ലെയിൻ എറർ. യാ, കണ്ടിന്യൂ. Then click on explain error. വെയിറ്റ്, അവർ കാണിക്കും എന്താണ് എറർ എന്നുള്ളത് കാണിക്കും. എന്നിട്ട് അത് അക്സെപ്റ്റ് കൊടുത്തു കഴിഞ്ഞാൽ ഓട്ടോമാറ്റിക്കലി അത് കറക്റ്റ് ആയിട്ട് വരും. ദാറ്റ് ഇസ് എ യൂസ് ഓഫ് കൊലാബ്. കൊലാബിലാകുമ്പോൾ ഇവിടെ ആ ഗ്രീൻ കളറിൽ കണ്ടോ കൊടുത്തേക്കുന്നത് എറർ ആണ്. ഗ്രീൻ കളറിലുള്ളതാണ് കറക്റ്റ് വൺ. സോ അക്സെപ്റ്റ് ആൻഡ് റൺ കൊടുത്ത് അത് കറക്റ്റ് ആയിട്ട് ഓട്ടോമാറ്റിക്കലി വന്നോളും. സോ കൊലാബ് യൂസ് ചെയ്യുമ്പോൾ നമുക്ക് ഓട്ടോമാറ്റിക്കലി എററുകൾ ഇങ്ങനെയുള്ളത് കറക്റ്റ് ചെയ്യാം യൂസിങ് AI ടൂൾസ്.
ഞാൻ അതിന്റെ മുകളിൽ കിടന്ന empty folder ക്ലിക്ക് ചെയ്തു.
എന്താണെന്നുള്ളത് പറയുന്നുണ്ട്. അതായത് ഇമ്പോർട്ട് അക്സെപ്റ്റ് കണ്ടിട്ട് ഇവിടെ ആ എറർ എന്താണെന്നുള്ള അക്സെപ്റ്റ് ചെയ്യുക. ആ എറർ പോയി. അപ്പൊ നിങ്ങൾക്ക്
പറഞ്ഞ നോട്ടിഫിക്കേഷൻ വരുന്നില്ല.
ഏതാ
മിസ്സിൻ്റെ ഇതിൽ നിന്ന് മിസ്സിൻ്റെ ഫോട്ടോ ഞാൻ ഡൗൺലോഡ് ചെയ്ത് ഡൗൺലോഡ് ചെയ്യുമ്പോഴത്തേക്ക് അത് 2 കോപ്പീസ് ഡൗൺലോഡ്സിലുണ്ട്. പക്ഷേ നോട്ട്ബുക്കിൽ ഫോട്ടോയിൽ
അപ്ലോഡ് ചെയ്യാനുള്ള ഓപ്ഷൻ
വരുന്നില്ല.
ഇത് സാമ്പിൾ ഡേറ്റ, അതായത് ഇത് ഫോൾഡർ അല്ല, ഫോൾഡർ ആയിട്ടല്ല ഇത് ചെയ്തേക്കുന്നത്. ഫോൾഡർ ആയിരുന്നെങ്കിൽ നമുക്ക് സിമ്പിൾ ഇതായിരുന്നു. ഇത് ഫോൾഡർ അല്ല, ന്യൂ ഫോൾഡർ, ന്യൂ ഫയൽ ആയിരുന്നു എടുത്തിരുന്നത്. അതിന്റെ പേരാണ് ഹാൻഡ്സ് ഓൺ. ഇതെല്ലാം ന്യൂമറിക്കൽ വാല്യൂസ് ആണ്. ലാസ്റ്റത്തെ ഓഷ്യൻ പ്രോക്സിമിറ്റി എന്നുള്ളതാണ് ന്യൂമറിക്കൽ വാല്യൂസ് ആണ് മനസ്സിലാക്കുന്നത്. I hope all of you downloaded the dataset and read, right? We read the dataset as data frame. Then we just display the information about the data. We got there are 10 features and number of non-null count and data type. Okay, here you can observe that there are 20,640 data, right? Among them, the total bedrooms. Check the value of total bedrooms. It consists of 20,433. Some values are missing, right? In this way, you can check the number of whether some values are missing or not. This is the one way. You can display the information, then check the number of non-null counts. And you can observe all the attributes are numerical except the ocean proximity field. That feature is a text field. You can also check in the data set. Okay. And the median house value is the house price which we need to predict. Median house value is our target variable, our label. That is the one we want to predict. Okay. Then the next step, we want to get the statistics of the data set. For each feature, I want to know what is the statistic, like minimum value, maximum value, what is the median, what is the mean value, standard deviation for that feature. For that, you can use housing.describe. Okay, and here you can see count is the total number of valid non-null rows, and mean is the mathematical average for that feature. STD standard deviation, that it tells how spread the value from the mean. Okay, then minimum value, we will get the minimum absolute lowest value, and maximum will give the maximum highest value, and the 25%, 50%, 75%. What that indicate? 25%, 50%, 75%. 25% means the first quartile. That means 25% of the data are lower than that value. Clear? 20 here in the case of total bedrooms, you can check 25% is 296. That means 25% of the houses have the total room less than 296. Okay, 25% of the data falls below this 296 value. Then 50% means 50% of data falls below that value. Here 50% is 1166. So 50% of data will be below that 116. And next 75% means 75% of data will be lower than that particular value, and remaining 25% will be greater than that value. Clear? So you can check the statistics of the data set using housing.describe. After getting housing.describe, you can check housing.head. Head will give first few columns of the data set. If you want to see the first few columns of the data set, you can use housing.head. The default value is 5. That means it will display 5 rows. If you want to display the top 10, first 10 rows, then you can use housing.head of 10. Within the bracket, you can specify that particular value. Default value is 5. Function call. Housing.describe ചെയ്തേനോ? Housing.describe. എവിടെയാണെന്നോ അത് ഹാൻഡ്സ് ഓണിനകത്ത് CSV ഹൗസിംഗ് കോപ്പി പാത്ത് ഇത് തന്നെ. ഇത് കറക്റ്റ് ആണല്ലോ? ഇത് റൺ ചെയ്തില്ലേ? എറർ കാണിക്കണം. ആ പാത്ത് ഒന്ന് കോപ്പി ചെയ്ത് കൊടുത്തു നോക്കി. ഇനി എറർ എന്തെങ്കിലും കാണിക്കുവാണെങ്കിൽ നിങ്ങൾക്ക് ഇത് ഇവിടെ ഇതുണ്ട്, എക്സ്പ്ലെയിനർ കൊടുത്താൽ മതി. എക്സ്പ്ലെയിനർ കൊടുക്കുമ്പം ഓട്ടോമാറ്റിക്കലി അവർ കാണിക്കും. എന്നിട്ട് അത് അക്സെപ്റ്റ് ആൻഡ് റൺ ചെയ്ത് കഴിഞ്ഞാൽ എന്താണ് എറർ എന്നുള്ളത് കാണിക്കും. എന്നിട്ട് അക്സെപ്റ്റ് ആൻഡ് റൺ കൊടുത്താൽ then next if you want to get the number of data, what is the dimension for that data, that means number of rows and number of columns, you can use housing.shape. That will give 20,640 rows and 10 columns. Then the house size will give total number of values. Housing.size will give total number of values. Okay. housing dot shape, then housing dot size. Then next, housing dot is null dot sum. That means if you want to check the number of null values for each column, you can use housing dot is null, then take the sum. Then you can see that the total bedroom, in total bedroom, 207 values are null. There may be the missing values. Housing dot is null dot sum. Then next, we want to analyze the distribution of each features. Okay, so this analysis is important because in order to understand the feature scaling, skewness of the data, outliers, variance, in order to understand all these things, you can use the distribution. For that, just plot the histogram, housing dot hist of beans equal to 50 and figure size, and then plot dot show. For plotting purpose, you are import matplotlib, the first header. In the first cell, we are importing matplotlib.pyplot as plt. Using this plt, you can plot. കൺജസ്റ്റഡ് ആയിട്ടല്ലേ ഇരിക്കുന്നത്, അത് കാരണം അത്രയും ഡേറ്റാസ് നമ്മൾ അതിനകത്തോട്ട് കൊടുക്കുന്നതുകൊണ്ടാണ്. അപ്പം നമുക്ക് ആകെ 4 ബാറൊക്കെ ഉള്ളെങ്കിൽ അത് വേരി മാറ്റി കൊടുക്കാം. If you click on this function side, you can see the number of parameters. What are the parameters in that function? Just click on that function's name. You can see what are the parameters, what is the data type for that parameter, like that. And here you can, from the plot, you can identify whether the feature is normal distributed one or rightly skewed one. Depending on the feature, we will decide. Suppose if you want to replace this value, here in total bedrooms we have some null values, right? So in order to clean the data, if we want to, one way is to remove that rows, otherwise another way is to fill that null values, right? Then in order to find out which value we want to replace, that can be identified from the distribution. If the data is normal distribution, you can replace that null value with a mean. But if it is a right skewed distribution, that means a long right tail, then replacing it with a mean is not an appropriate thing. It is highly sensitive to the mean value. That time you can replace it with a median value. There are a lot of things in that that will be comes under feature engineering. Okay. Then here you can see the total rooms. Here you can see the total rooms is a right skewed distribution. There may be a chance for the presence of some kind of outliers, some noises, right? But this median house value that follows some almost a normal distribution, and median income that follows the normal distribution. Okay. Then next I want to understand the correlation. What is the correlation between the features? Is there any correlation between these features? Is there any correlation between the number of rooms and the price of the house? Is there any correlation between salary, income with house price? So for that, you can use this correlation function. Definition, find correlation and give the numeric values. And then you can print the correlation coefficient in sorted order. And here you can see the median income is highly correlated with house price, right? The median income's value, correlation value is 0.688. That is highly correlated with our house price. That feature is highly correlated. Suppose if you want to use for the simple linear regression, we will use only one feature, right? Then which feature we will select? That time you can use this correlation concept. That means here you can see the income is highly correlated with what? House price. Okay. അല്ലാതെ നമുക്ക് ഡയറക്റ്റ്ലി ഫങ്ഷൻസ് യൂസ് ചെയ്യാം. Actually, here the function is defined one. You can use the already inbuilt functions like pairs and correlation coefficients. Some functions are already available. You can Google that. Instead of writing the code, you can use that function. You can just call that function. Then next, in the question itself, they mentioned that, yeah, predict house price based on a single feature. Example, the average number of rooms per dwelling. Okay, so you have to calculate the average number of rooms per dwelling. Why we choose that thing? Rather than focusing on a single feature, we are going to calculate the average number of rooms per dwelling. That means, in some cases, based on the location, that means some location the population will be very high, right? In that case, the number of rooms will be high in that location. If you take the average number of rooms in that particular location, it will be high because the population is high. But in some other location, population may be very low. In that case, the number of rooms, average number of rooms in all the houses will be low. So, rather than directly taking these row by row values, the better way is to take the ratios. Okay, that means we are calculating the total number, average number of rooms per location. Okay. Otherwise, you can directly take a single feature, but here in the question itself, it is directly mentioned, take the average number of rooms per dwelling. So, that is calculated using housing of rooms per dwelling is equal to housing of total number of rooms divided by housing household. Household means total number of household means a group of people residing within a home unit for a block. So obviously the total number of rooms will be depending on the number of household, right? So calculate the rooms per dwelling equal to total rooms divided by household. Then we are going to take this as the x value. This is our feature. Rooms per dwelling is our feature, right? That we calculated. Then using that, we want to predict the median house value. So our y value is housing of median house value. We are copying the values of these two columns into x and y. Our aim is to predict y, right? Y is equal to mx plus b. Here y is the prediction, median house value, right? And equal to y is equal to mx plus b. X is our feature. Here we are using only single feature, and that feature is how rooms per dwelling. Clear? So, firstly we identified which feature I am going to select, then calculate that feature and put it into the x value, then y will be our target value. Then, after getting x and y, Next, we are going to divide these entire data set into two sets, train set and test set. Right? Here, I took the ratio 80% for training purpose and remaining 20% for testing purpose. For that, you can use train test split. Okay, that is we imported from here in the head, the first cell, we imported from sklearn.model selection, import train test split. We are importing the function train test split. Then we are dividing the data set into two sets, 80% for training and the remaining 20% for testing. So giving the features x, y and the test size as 0.2, that means 20% is used for testing and 80% for training, right? So here we are specifying the test size as 0.2 and random state is equal to 42. That random value I fixed that because for every simulation, if I am not setting that random value, then for every simulation I will get different results because this split random training and test split are done randomly. So every time when we are running this thing, we will get for the data, the raw selecting for the training will be different from another simulation. So in order to get a constant result, we can set that random state as a 40. Any number you can give. Just understand that thing. If you are not giving that thing, it is not an issue. The difference is there may be some minute variations for each run. Then next I am going to perform the normalization, standardization of the features. For standardization, I scaled the value, the trained values as x minus mu by sigma. Mu is the mean value and sigma is the variance. Okay. After this normalization, the feature values will be scaled to some particular range, like -1 to 1. So firstly, we will take the mean value, then take the standard deviation, then x train minus x mean divided by standard deviation. Here, you can observe And the test, the train test list, that function will return 4 things. What are they? X train, the features used for the training purpose, and X test, their corresponding features used for testing purpose. Then Y train, target variables of trained features. Then Y test, target value of test features. 4 things are returned. Okay. Then next, I performed some normalization. Here you can observe mean value, the feature mean and feature standard deviation are calculated based on the trained data, right? Here within the function, you can see X train is passed, right? Rather than passing the entire data, we are calculating mean and standard deviation using the data used for training. Okay. Then we calculated X train scaled using X minus mu by sigma equation. Then X test scaled also we scaled using X test minus X mean divided by X standard deviation. In that case, we used mean and sigma. Which mean and sigma is used? Mean of standard deviation of training features. Why? ട്രെയിൻ ടെസ്റ്റ് സ്പ്ലിറ്റ് ചെയ്തു. അതിനുശേഷം നമ്മൾ അതിനെ നോർമലൈസ് ചെയ്യുകയാണ്. എന്തിനു വേണ്ടിയിട്ടാണ് നോർമലൈസ് ചെയ്യുന്നത്? നോർമലൈസ് ചെയ്ത് ഒന്നുമില്ല, പെർഫോം ഒന്നും സംഭവിക്കാൻ പോകുന്നില്ല. പക്ഷെ നമ്മുടെ പെർഫോമൻസ് ചിലപ്പോൾ ഫീച്ചേഴ്സ് ഒരുപാട് വാല്യൂസ്, പല ഫീച്ചേഴ്സ് പല റേഞ്ചിലായിരിക്കാം. അപ്പൊ അതിനെ നമ്മൾ ഒരേ റേഞ്ചിലോട്ട് കൊണ്ടുവരാൻ വേണ്ടി നോർമലൈസേഷൻ ചെയ്യുന്നു. പലതരത്തിലുള്ള നോർമലൈസേഷൻ ഉണ്ട്. ഇപ്പൊ നിങ്ങൾക്ക് 0ക്ക് 1 ഇടയ്ക്കാണ് നോർമലൈസേഷൻ ചെയ്യുന്നതെങ്കിൽ അതിന് 0ക്ക് 1 ഇടയ്ക്കുള്ള വാല്യൂസ് ആണ് വേണ്ടത്, അതിലൊരു നോർമലൈസേഷൻ ഉണ്ട്. ഇനി അതല്ല -1നും 1നും ഇടയ്ക്കാണ് വേണ്ടതെങ്കിൽ അതിലൊരു നോർമലൈസേഷൻ ഉണ്ട്. ഇപ്പൊ ഇവിടെ ഞാൻ ചെയ്തേക്കുന്ന നോർമലൈസേഷൻ എന്താണ്? വാല്യൂ മൈനസ് മീൻ ബൈ സിഗ്മ. It will be -1 to 1 റേഞ്ചിലുള്ളതായിരിക്കും. ഓക്കെ. ഇവിടെ നോർമലൈസ് ചെയ്യുമ്പോൾ ഞാൻ മീനും സ്റ്റാൻഡേർഡ് ഡീവിയേഷൻ ഫീച്ചറിന്റെ മീനും സ്റ്റാൻഡേർഡ് ഡീവിയേഷനും കാൽക്കുലേറ്റ് ചെയ്തത് ട്രെയിൻഡ് ഡേറ്റ വെച്ചിട്ടാണ്. അതായത് ഡേറ്റയെ രണ്ട് സെറ്റായിട്ട് ഡിവൈഡ് ചെയ്തിട്ടുണ്ട്. ട്രെയിൻഡ് ഡേറ്റ ആൻഡ് data for the കാൽക്കുലേറ്റ് ചെയ്ത് വെച്ചിരിക്കും. അതേ എന്നിട്ട് അത് വെച്ചിട്ട് എന്ത് ചെയ്തു? ആ ട്രെയിൻഡ് ഡേറ്റാസിനെ എല്ലാം ഞാൻ നോർമലൈസ് ചെയ്തു. ഓക്കെ, ഇനി നമുക്ക് അടുത്ത ടെസ്റ്റ് ഡേറ്റയെ ടെസ്റ്റ് ഫീച്ചറിനെ നോർമലൈസ് ചെയ്യും. അന്നേരം ഞാൻ യൂസ് ചെയ്ത മീനും സിഗ്മയും ഏത് തന്നെയാണ്? ഈ ട്രെയിൻഡ് ഡേറ്റയുടെ മീനും സിഗ്മയും തന്നെയാണ്. എന്തുകൊണ്ടാണ്? അതെന്തിനാന്ന് വെച്ചിട്ടുണ്ടെങ്കിൽ നമ്മുടെ പർപ്പസ് എന്ന് വെച്ചാൽ ഈ ടെസ്റ്റ് ഡേറ്റ എൻറ്റയർലി ന്യൂ ആയിരിക്കണം ഫോർ ദ മോഡൽ. അതായത് ടെസ്റ്റിംഗ് നടത്തുമ്പോൾ that test data should be entirely new for that model. അതുകൊണ്ടാണ് നമ്മൾ അതിന്റെ മീനും സിഗ്മയും കാൽക്കുലേറ്റ് ചെയ്ത് അത് വെച്ച് നോർമലൈസ് ചെയ്യുക. സംതിങ് ലൈക്ക് നമ്മളൊരു ഡേറ്റ ലീക്കേജ് അവോയ്ഡ് ചെയ്യാമെന്നൊക്കെ പറയും. അതൊരു റൂളാണ് മെഷീൻ ലേണിംഗിൽ നമ്മൾ യൂസ് ചെയ്യുന്ന ഒരു രീതിയാണ്. ഓക്കെ, അത് കീപ് ഇൻ മൈൻഡ്. നമ്മൾ നോർമലൈസേഷൻ ചെയ്യുമ്പോൾ ടെസ്റ്റ് ഡേറ്റയെ നോർമലൈസ് ചെയ്യുമ്പോൾ നമ്മൾ ആ ട്രെയിൻഡ് ഡേറ്റയുടെ മീൻ standard deviation system. In order to keep the test data should be unknown to the model. Then we are going to linear regression. This function here രണ്ട് രീതിയിൽ ഫങ്ഷൻസ് എഴുതിയിട്ടുണ്ടോ ഒന്ന് നമ്മൾ ഡിഫൈൻഡ് ചെയ്തതും അതാണ് ആദ്യത്തെ രണ്ട് സെല്ല്. പിന്നെ ഒരെണ്ണം അല്ലാതെ ഇൻബിൽറ്റ് ഫംഗ്ഷൻ ലീനിയർ റിഗ്രഷൻ എന്ന് പറയുന്ന ഫംഗ്ഷൻ ഇൻബിൽറ്റ് ഉണ്ട്, അത് ഇമ്പോർട്ട് ചെയ്ത് ഫംഗ്ഷൻ കോൾ ചെയ്യും.
Can I have a small tea break? Please have it outside. Please have it. 15 minutes പറയാം അല്ലേ? Be back by 11:20.
ചെറിയ വാല്യൂ പ്രൊഡക്ഷൻ ചെയ്യുന്നു.
മീൻ സ്ക്വയർ
ലാസ്റ്റ് ഔട്ട്പുട്ട്
മനസ്സിലായി
വാല്യൂ ലാസ്റ്റ്
Linear regression, in the case of linear regression, it is okay. But if you move to another algorithms, it will be difficult to write the code itself. So better is to use the inbuilt functions from the Python predicates. Then here in gradient descendant, what is gradient descendant? We are trying to, yeah. Actually, our aim is to find the parameters. Y is equal to mx plus b. We need to find out the slope and intercept that best fit these data. Okay. Then we need to find out the parameter. Using mathematically direct equations, we can calculate the value of m and b from the set of data. Okay. That is the known as direct linear regression using equation. Okay. Then another one is using gradient descendant. In gradient descendant, actually what we are doing, it is an iterative approach. Okay. In iteratively, we are finding out the values of m and b. For that, what is the first step? Initialize the variables randomly. Here, I initialize it with 0. M and b are set to 0. Yeah. Initialize m and b with 0 and learning rate is set to 0.01. What is learning rate? Yeah, at each step, what we are doing, means what will be the length of the step. That means only from the current position, I will check the gradient. Okay, then I want to move forward, move downwards. Then for that, how much amount I will move. That will be decided by the learning rate 0.01. If it is very too small like 0.0001, then that time reaching the minimum value will be slow. Okay, because too many iterations are there. At every step, we will make small step. So reaching the minimum will take long time. Convergence will be very slow. Then, if we set the alpha value to very high value, then what will step? There is a chance to miss the minimum value. Then there is a chance to oscillate in between minimum and maximum like that. There is a possibility to miss the convergence. Okay. Then here you can try the different values of alpha. Learning rate you can try with the different values. Okay. Here I set it as 0.01. Then epochs with 1000. Then took the number of trained samples, length of the samples. Then I try to calculate then y equal to mx plus b is our basic equation. Then we will calculate the cost as mean of y trained minus y predicted the whole square. That means sum of mean square error. Then we will calculate if it is less than the previous cost. If the current cost is less than current cost is the difference between the previous cost and current cost is less than 0.001, we can converge. That means we reach the minimum point. Then, if it is not minimum, then we will set the previous cost as the current cost. Then we will differentiate. That means we are calculating the gradient dou j by dou b and dou j by dou a. In the first day we will discuss the cost and how to calculate the gradient by using the partial derivative. For that we have the derivation, and how we are implementing that equation. Then after calculating gradient, then we are updating the parameters m is equal to m minus learning rate alpha into dm. The same way b is equal to b minus alpha rate into dt. Okay, this is the method to calculate the gradient descendant. Then after that, after setting the model, you can predict. Why predict gradient is equal to m into, you can give the test value, test features. Our equation is y is equal to mx plus b, right? Now we got the value of m and b. We got the value of m and b with the minimum cost, right? Then you can pass that m and b and we can test with the x test scale. Then you will get the predicted values in y. Okay? Then you can evaluate the gradient descendant using mean squared error and R2 square. Okay? Then you can see that with the gradient descendant, the slope is 18,323 and the intercept is this much amount. Then mean square error and R square is also calculated. Then we move to the linear regression using the normal equation. That means the mathematical metrics. Using matrix method, we are calculating the linear regression. This is the normal equation like x transpose, x means the features, x transpose into x inverse, then multiply it with x transpose into target variable y. Okay. Here you can see x train n e equal to np dot. Here the c underscore np dot c means we are adding a column of 1. We are appending a column of 1 to the features. For the purpose of here you can see that our actual equation is y is equal to mx plus b, right? So along with b we are adding some more variable x0. That is why we are explaining our hypothesis equation is h theta of x is equal to theta 0 x0 plus theta 1 x1. Right? Then we are adding one columns of 1 to the features. Then calculating theta values. This x train dot ne dot this equation, this line, this line implementing this one, theta is equal to x transpose x raised to minus inverse x transpose y. That is here we are breaking. Then we are calculating the final intercept as theta 0 and slope as theta 1. Okay. After taking the product, after calculating theta, we will get theta 0 as intercept and theta 1 slope. Then we can predict. Okay. From both the cases, then try to predict, then calculate the mean square of error and R2 square. Because you can observe the results are almost same. If you are run, then you can observe the results are almost same. In both gradient descendant and linear, directly using linear regression. The only difference is that linear regression we are calculating using mathematical multiplication, mathematical method, right? In gradient descendant, what we are doing? We are some iterative approach is performing, right? So in this data set, we got the almost the same result. And from the plot, you can understand that the line does not fit properly. Meaning, the feature may not be apt for our prediction. The feature we took is number of rooms per dwelling, right? So it may not be good. You can tell the students to try with different features. Instead of directly giving the question, we can just give the idea, then ask them to try with different features. And with different learning parameters also they can change. Okay? Clear? നമ്മുടെ പാരാമീറ്റേഴ്സ് ചേഞ്ച് ചെയ്ത് കൊടുത്തു നോക്കാൻ പറയാ, ഫീച്ചേഴ്സ് പലത് കൊടുത്തു നോക്കാൻ പറയാ, അങ്ങനെ അവർ ആ കൺസെപ്റ്റ് എന്താന്നുള്ളതിലോട്ട് ഡയറക്ട്ലി ഇത് 0.001 കൊടുക്കുക, ഹൈഡ്രേഷൻസ് 1000 കൊടുക്കുക, അങ്ങനെയല്ല പറയണം. അത് മാറ്റി കൊടുക്കട്ടെ. എന്താ സംഭവിക്കുന്നത് പ്ലോട്ടിൽ നിന്ന് കാണട്ടെ. ഇതിൽ ഏതാണ് ഏറ്റവും ബെറ്റർ എന്നുള്ളത്. പിന്നെ നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്ത് വരുമ്പോൾ മീൻ സ്ക്വയർ എറർ ഷുഡ് ബി ലോ ആൻഡ് R square should be high. Here നമ്മൾ രണ്ട് കേസിലും നമുക്ക് ഓൾമോസ്റ്റ് സെയിം തന്നെയാണ് റിസൾട്ട് വന്നിരിക്കുന്നത്. ബിക്കോസ് ഒരെണ്ണം ഈ ഹൈഡ്രേറ്റ് അപ്രോച്ച് വഴി കാൽക്കുലേറ്റ് ചെയ്ത് വരുന്ന ഒരെണ്ണം ഡയറക്റ്റ് മാത്തമാറ്റിക് ഇക്വേഷൻ വെച്ച് ചെയ്യും. ഡിഫറൻസ്. Then next we move to the second experiment. Polynomial regression. I will upload the file in Drive. Yeah, uploaded. You can check the file. Downloaded. You can just search the dataset auto MPG dataset to predict MPG. This auto MPG dataset, it is already available in Cable. Here you can see the details. DEPT codes are available with this data set. Here, our aim is to implement polynomial regression on the auto-integer dataset to predict miles per gallon based on engine displacement and compare polynomial regression with linear regression. So, first step is to implementing, or we are importing all the packages, and here I am using this instead of directly downloading. Downloading from the Kaggle, I used the built-in MPG dataset from Seaborn. Seaborn is an open Python library. From that, we can download, we can access this dataset. For that, you have to import Seaborn as SNS. Okay. Then load this dataset SNS.load dataset of MPG. Then it is read as data frame. Then you can print the first 5 rows using head function. These are the features and values. And by printing df.information, we can give the number of columns. There are 9 columns are there in PG, cylinders, displacement, horsepower, and the number of non-null values and data type. Then here you can see there are some values are missing in horsepower. Then our aim is to predict MPG based on engine displacement. Here also we are using only one feature, engine displacement. In engine displacement, we have no missing values, and MPG also we have no missing values. But if there are any NA values or missing values, you can drop that one. This is a one kind of pre-processing step. If there is any kind of missing values, you can, one thing is you can replace that missing value with some other number or drop that row. And for dropping, you can use this. First is SNS.load dataset. Okay. Then drop NA. Drop NA. Then inside the drop NA, you can specify what are the features you are looking. Okay. So I am just checking displacement and MPG because here I am using only displacement for predicting MPG. Okay. So I took that 2 columns. Then remove if there are any NA values, then remove that rows. Then set X as displacement and Y as MPG value. Y is the value. MPG is we want to predict based on displacement value. In the question itself, it is given displacement. We have to predict NBT based on the displacement. That is why we are taking X as displacement. Actually, in our case, there is no missing value. So, the ചെയ്യേണ്ട കാര്യമില്ല. Missing value ഇല്ല. പക്ഷേ എന്തായിരുന്നെങ്കിൽ എന്ന് പറഞ്ഞ് കാണിക്കാൻ വേണ്ടിയിട്ട് ഞാൻ ചെയ്യുന്നേ ഉള്ളൂ. ശരിക്കും അത് ചെയ്യേണ്ട കാര്യമില്ല. ബിക്കോസ് അതുകൊണ്ടാണ് നമ്മൾ ആദ്യം നമ്മൾ ഇൻഫോർമേഷൻ എടുത്തത്. ഇൻഫോർമേഷൻ എടുത്തപ്പോൾ ആ രണ്ട് ഫീച്ചേഴ്സിന് there is no missing value. So, ഡ്രോപ്പ് ചെയ്യേണ്ട കാര്യമില്ല. പക്ഷേ ഇത് ഇങ്ങനെ കാണിക്കാൻ വേണ്ടി എടുക്കുന്നു. Then next step, train test split. Data set X trained. For that train test split, we are importing, right? Yeah, from sklearn.model selection, import train test split. That already we imported. Then we are performing the test of X feature. X here feature is displacement, and Y is our target. Here our target is NBG. Then test size is 0.2. That means 20% is used for testing. Then random state is equal to 42 in order to avoid some kind of randomness. Okay. Then after that we are going to build the multi-degree model. Here we are using polynomial, right? And actually, our question is implement the polynomial regression with the varying degrees and compare it with linear regression. Linear regression is a kind of polynomial regression with the degree 1, right? If our degree is 1, that means it is a linear regression, straight line. So, I'm going to check with degree 1, 2, 3 and 4. I'm comparing 4 degrees. Degree equal to 1 indicate it is a linear regression. That means polynomial degree 1 means linear regression. And for each degree in degrees, we are calculating polynomial features of degree equal to degree. Here we are implementing standard linear model with a degree 1 and quadratic model with a degree 2 and cubic model with a degree 3 and one more model with a degree 4. Okay. Then we use polynomial features to generate the higher input. That means we are converting the input features into the polynomial form. If degree equal to 1 and the original feature is x, okay, degree equal to 1, that means we are going to implement the linear model and our feature is x, then the transformed feature will be in the form of 1x. Okay, then if our degree is 2 and our feature is x, then our transformed feature will be 1x x square. Okay, then if our degree is 3 and our feature is x, then it will be transformed to 1x x square x cube. Like that way we will convert our feature depending on the degree. Then here we use that means polynomial features we are implementing. We are taking these polynomial features of degree 1. If it is 1, then this poly.fit transform of x training. That means we have the training data, training features in x train, right? That features we will transform into the polynomial forms. That means if it is 1, then poly.fit transform will convert it into 1x x square x cube. Like that way it will be converted. That means that feature will be converted in the form of polynomial equation. Okay. That means if our training variable is 2, 3, then for degree equal to 2, it will be after running poly.fit transform, it will be transformed to 1, 2, 4. That means the first one, the feature 2 is transformed to 1, 2, 4. Okay, then feature 3 is transformed to 1, 3, 9. Why? Because the degree is 2. That means 1, x square, like that way, 1, 2, 2 square, 1, 3, 3 square. In that way, we are converting each feature. If our degree is 3, then this 2 will become 1, 2, 4, 8. Okay? Like that way, we will, this poly dot fit transform of x means it will convert into the polynomial equation. Each data point will be converted to the polynomial equation. Then next step is poly dot transform of x test. That means the test data also we will transform. Okay, why applying on the tested data? Why we are not using fit underscore transform? We are just calling transform. Here we are applying just poly dot transform, not poly dot fit underscore transform, right? That means poly dot fit underscore transform means poly dot fit plus poly dot transform. Okay, the fit means we are transforming we are learn the transformation from the training data. What we need to do, that will be learned from using fit function. Then accordingly it will be applied to x. That means if the degree is 1, then the model will learn what I need to do. What kind of transformation I need to do. That will learn. Then after that, it will apply to that data using transform function. Okay. So in our case, initially we will learn poly dot fit transform. Yeah, the model will already learn. Then that same transformation will be applied to the test data. Again, no need to learn, no need to perform, or no need to fit the data. Other than നമ്മൾ fit underscore കൊടുക്കും. Then you can call the linear regression function. In the previous experiment, നമ്മൾ linear regression code directly എഴുതുമായിരുന്നു അല്ലേ? അതിന് പകരം നമുക്ക് എന്ത് ചെയ്യാം? Just ഫംഗ്ഷനെ കോൾ ചെയ്യാം. Model is equal to, our model is linear regression. This creates a regression model. അത് യൂസ് ചെയ്യണമെന്നുണ്ടെങ്കിൽ എന്ത് ചെയ്യണം? From sklearn.linear model import linear regression. Then only we can use. Okay, linear regression. If you want to call the linear regression function directly, you have to import it from sklearn.linear model import linear regression. And you can directly call that function. Model create ചെയ്തു. Then എന്ത് ചെയ്യണം? Next we are going to fit that model into trained features and trained target variables. That means model will learn the coefficients for, okay, that means for degree equal to 2, we want to learn b, w1, w2. That means if our degree is 1, our coefficients are y is equal to bx plus, and it's w0 x plus w1. Our coefficients are w0 and w1. The same way for degree the coefficients will be different, right? And for degree 3 it will be increased. Number of coefficients will be increased. So using fit function, these coefficients will be found out. Okay. Then learn the coefficients. Then using that coefficients, we are going to predict model dot predict of, then passing the test features. Right? We already split the data into trained features and test features, right? Then at the time of prediction, we will pass these test features. Clear? Then calculate the mean square error of test target minus predicted target. Predicted target means for test features we are predicting. But its actual target are already or actual values are already stored in by test at the time of train testing speed time. Then we are calculating the mean square difference between this actual value and predicted value. That will be stored in MSC, and the same way we will calculate R square score. Okay, then print. Then in here you can see for polynomial degree mean square error is 18. For R square it will be 0.66. By increasing the polynomial degree, mean square error is reduced, and R square is increasing. That means accuracy by increasing the degree, our error is reduced and accuracy is increasing. If we plot the curve, we can prove that. That means sometimes it is considered as a polynomial regression rather than linear regression. The degree equal to 1, higher degree നമുക്ക് കുറച്ചും കൂടി കൂടുതൽ റിസൾട്ട് വരും ലീനിയർ റിഗ്രഷൻ എടുക്കുന്നതിനേക്കാൾ ബിക്കോസ് ഡിസ്പ്ലേസ്മെന്റും എംപിജിയും തമ്മിൽ ഡയറക്റ്റ് റിലേഷൻഷിപ്പ് ലീനിയർ റിലേഷൻഷിപ്പ് കാണില്ല നിങ്ങളത് ചിലപ്പോൾ ആ പ്ലോട്ട് പഠിച്ചു നോക്കിയാൽ അറിയാം സോ ദാറ്റ് വി ക്യാൻ യൂസ് polynomial regression. Another implementation, bridge and lasso regression. I uploaded that one. Uploaded that file, you can check that. The next one is implement bridge and lasso regression in on the diabetes dataset and compare the performance of these regularized model with standard linear regression. The regularization techniques we used are bridge and lasso and tune the hyperparameters using cross division and compare the performance using MSC and R squared with the standard regression model. Here, the dataset we used are diabetes. It contains 10 variables like age, sex, BMI, average blood pressure, and 6 blood serum measurement for 442 patients. That means our number of rows is 442 and number of columns maybe 10, right? And the target variable is quantitative measurement of disease progression 1 year after baseline. Okay? And here age in years, sex, binary variable, BMI, body mass index, BP, blood pressure, and S1, S2, 6 variables are there. This indicate 6 blood serum measurements. Okay, these are the 10 features. Then our target is progression. That means a quantitative measure of disease progression 1 year after baseline. Then what's the problem here is that when a linear model contains a lot of features, then a standard linear regression can become highly sensitive to noise or multicollinearity. That means multicollinearity means features are when the features are strongly correlated. That situation is known as multicollinearity. Okay? In that cases, linear regression may not work well. So that time you can use some regularization techniques. Two techniques are bridge and lasso. Okay? Then in standard linear regression, what we are trying, our goal is to minimize the error. Error in the sense the difference between the actual value and predicted value, right? So here we are calculating our errors mean squared error. That means average of square differences between the actual value and the predicted value. MSC. Then, okay. Then so regularization. What is happening in regularization? Regularization modifies our loss function, mean square error function, by adding an extra term, by nullity term, by multiplying the hyperparameter alpha. That means here the loss function equal to our here our cost function is mean square error, right? So while calculating mean square error, with the mean square error, we will add one more term, right? Alpha into sigma j is equal to 1 to p beta j square. That beta indicate the coefficients. Okay? So in rich we will square the coefficient, then multiply it with alpha. That quantity we will add to our cost. Okay? Then, but in coming to lasso, we will take the modulus value of absolute value of coefficient, then multiplied with alpha, then that quantity will be added to the cost function. Okay, that is the difference. Here in rich we are just squaring the coefficients. In lasso we are taking the absolute modulus value. Then actually what is happening if we are not using the regularization? For example, if we have two features BMA and weight, they are highly correlated, then in that case the coefficients will be too large. Okay? If the two features are highly correlated, then while after modeling we will get high value coefficients. So in that case, when a new patient, suppose a new patient has slightly different measure, then that times, because the coefficients are very large, small change in BMI and weight can cause large change in prediction. Because our coefficients are very high. So, if the new data will be slightly different from our trained data, then that also will affect our predictions. Because of the large value of the coefficient. Okay, so we want to suppress the coefficients of some features. Then for that we can use regularization. Then, yeah, in order to find out the value of alpha, we are multiplying with alpha, right? So, which value? What will be the value of alpha? For that, you can use the cross validation test for a wide range of alpha values. Then, yeah, for that, firstly, you can import the files. Here we are importing linear regression, rich, CV, rich C means rich cross validation, lasso, CV. Then importing the measures, mean squared error and R squared score. And the data set also. Here we want the diabetes data set, right? That also we can directly import from SKLearn because SKLearn already have that data set. So you can directly import that data set from SKLearn. These are the packages we import. Then load the data set using load underscore diabetes. Then suppose if you want to see what are the features in that data set, you can just type diabetes.feature name. Then you will get what are the features like age, sex, BMI, BP, S1, S2 to S6. Then take the data as X value. Here, how many features are we are selecting? In the previous two example, we are for the regression purpose we are only using only one feature. Here we are taking the entire 10 features. Okay. നമ്മൾ നേരത്തെ ചെയ്ത തൊട്ട് മുന്നേ ചെയ്ത പോളിനോമിയൽ റിഗ്രഷനിൽ ഡിസ്പ്ലേസ്മെന്റ് ഫീച്ചർ മാത്രമേ എടുത്തിരുന്നുള്ളൂ അല്ലേ? So that displacement will be assigned to the x. Right? Here x ന്റെ സ്ഥാനത്ത് എന്താണ് വരുന്നത്? ആ 10 feature values വരും. Then y will be the diabetes target. And that is disease progression measure after 1 year. And feature names is diabetes dot feature name. Then in order to find out the dimension, you can just print x dot shape and y dot shape. X has the size 442 rows, that means 442 patients, and 10 columns, that means 10 features. And y dot shape 442 rows, that means for each patient we have output variable y, and column we have only one column, right? Target column എത്രയാണ്? ഒരു column ഉള്ളൂ. The previous two examples we are taking only one feature. Based on that one feature we are making some predictions. But here we are considering entire feature. That is why we are taking x is equal to diabetes dot data. That data will assign the entire features into x. Then based on this x we are going to predict y. Then here also scaling the feature values is very important in ridge and lasso regression, because the difference between the values, for example, if age is in between 20 and 80, but another feature in them has a different range of values. So that kind of things will affect our model's performance. Okay, that time we have to perform some standardization. നമ്മൾ നേരത്തെ ചെയ്ത രണ്ട് എക്സാമ്പിൾസിലും സ്റ്റാൻഡർഡൈസേഷൻ നമ്മൾ ഡയറക്റ്റ്ലി എന്താ ഇക്വേഷൻ എടുത്ത് കൊടുക്കുമായിരുന്നു. എങ്ങനെയായിരുന്നു? എക്സ് മൈനസ് മ്യൂ ബൈ സിഗ്മ. അങ്ങനെ ചെയ്യുന്നതിന് പകരം നമുക്ക് വേറൊരു പാക്കേജ് ഉണ്ട്, ഒരു ഫംഗ്ഷൻ ഉണ്ട്, അതാണ് സ്റ്റാൻഡേർഡ് സ്കെയിലർ. സ്റ്റാൻഡേർഡ് സ്കെയിലർ is used for performing or scaling the feature values. That should be imported from sklearn dot preprocessing. It is a preprocessing step, right? So sklearn dot preprocessing import standard scalar. In order to use the standard scalar function, you have to import that from sklearn. Instead of writing the equation x minus mu by sigma, you can use this standard scalar function for standardization purpose. Then scalar will be our model. It will be transform the extract values and test values. That means after that we will get standardized values, normalized values. We will get our trained features and test features will be normalized. Here also X test scale uses the mean and sigma of trained data. Okay. നമ്മൾ നേരത്തെ പറഞ്ഞ പോലെ തന്നെ ടെസ്റ്റ് ഡേറ്റ സ്കെയിൽ ചെയ്യുമ്പോഴും ഏത് മീൻ സിഗ്മയാണ് യൂസ് ചെയ്യുന്നത്? ട്രെയിൻഡ് ഡേറ്റയുടെ മീൻ സിഗ്മ in order to avoid the data leakage. Then we need to compare this ridge and lasso regression with a linear regression or ordinary linear regression technique. For that, firstly we have implemented the linear regression model. LR is equal to linear regression. We are calling that function. For that, you have to import the linear regression. Here you can see from sklearn.linear model import linear regression. Also, you are importing ridge CV and lasso CV. That should be imported. Then, yeah. Then fit that model with our trained features and trained target variable. Okay. Then our next step is to we have to perform for wide range of values of alpha. Okay. Then we need to take the best one. Okay. For that, alpha values can be nb dot log space of minus 4 to 400. That means alpha value we are generating 100 values in between 10 raised to minus 4 and 4. Okay. Different alpha values നമുക്ക് ഇത് ടെസ്റ്റ് ചെയ്യണം. അതിന് വേണ്ടിയിട്ട് different alpha values ടെസ്റ്റ് ചെയ്യാൻ വേണ്ടി ജനറേറ്റ് ചെയ്യാൻ വേണ്ടി ഞാൻ എന്താ ചെയ്യുന്നത് 100 values എനിക്ക് ജനറേറ്റ് ചെയ്യണം in between 10 raised to minus 4 and 10 raised to 4. അതിന് വേണ്ടിയിട്ടാണ് ആ log space nb dot log space എടുത്തേക്കുന്നത്. Then I am going to call the ridge regression. Ridge CV or ridge CV is equal to ridge CV of alpha is equal to alpha. Here I created 5 alpha values and CV equal to 5 means here I am performing cross validation, 5-fold cross validation. What is 5-fold cross validation? That means training data is divided into 5 folds. Okay, then fold 1 to fold 5. Okay, 5 subsets are training data divided. Then next step, use fold 1 to 4 for training. Okay, then 5th fold for validation. Data set in number train test step divided. Then again that trained data set will be divided into test, train and validation. So the entire training data set in number 5-fold divided. Then from 1 to 4 will be for training, 5th for cross validation. The other iteration is 1 in a validation, 2 to 5 cross validation. And 5 variations we will perform. Then take the average value. That is the meaning of cross validation. It is mainly used for avoiding the underfitting. Overfitting. Okay. That is why we are putting CD is equal to 5. Ridge CD, alpha is equal to alpha, CD is equal to 5. Then, after creating the model, you can fit that model to our scaled trained features to and trained target variable. After creating the ridge model, we are going to fit that model to scaled trained features and trained target. Okay. Then again perform the lasso with 5-fold cross validation. Here also you can call lasso CV. It should be imported from sklearn linear library import linear regression ridge CV lasso CV. Okay. Should be imported. Then here you can provide CV is equal to 5. That means we are performing 5-fold cross validation, and here maximum iteration is set to 1000 because lasso uses an iterative algorithm. So sometimes it needs many iterations to convert. So set that value. Then fit that model to our trained data. Okay. Then after getting, you can print the optimal alpha value and optimal alpha value for ridge regression and lasso regression. Ridge regularization and lasso regularization. That means ridge CV dot alpha. That will give the better alpha value. Okay. Then next we want to compare our models like the linear regression, ridge, and lasso. For that, you can just print them. Here you can see our mean square error is reduced after applying ridge and lasso. And also R square value is increased after applying ridge and lasso. That means after applying regularization, our performance is increased from linear regression. Okay. After applying regularization, our performance is increased. Then we can check the feature coefficients, how they are reduced, suppressed. Actually, these are the features, and in linear regression, our coefficient for each features are this one. After applying regression, ridge regularization, you can see the change in the coefficients. Some coefficients are reduced, suppressed, right? And in lasso also, they are reduced. And in lasso, the difference is that some features are neglected because the coefficients, because of for some features like H, S2 and S4, the coefficients becomes 0. The coefficient becomes 0 means that features are neglected, right? But if you want to keep all the features, then you can use the rich regularization technique. That's the difference between rich and lasso. By reducing the coefficient, we will get more simplified model. Here we have 10 features. So we can neglect, we can remove some features by setting the coefficients to 0 using the regularization technique. From this, we can see that the most influential features can be the BMI, BP, and S1 because their coefficients are high. Okay. Then next we can move to the for saving your collab in PDF format, you can just file. Either you can download as .ipy in the or py, and otherwise we can click on print and save as PDF, and you will get the PDF file. Yeah. And the next one is
Let's break it.
ആരില്ലാത്ത സേഫ്റ്റിക്ക് വേണ്ടിയിട്ട് ഇതിന്റെ ലോകം